Okay, lesson 7. So we're looking at polynomial function graphs now. So fill in the blanks in the following statement regarding the function of y equals p of x. The zeros of the function, the x-intercepts of the function, and the roots of the corresponding equation, y equals 0, are all the so all of those are the same number. Unique factorization theorem. This theorem states that every polynomial function of degree n greater than or equal to 1 can be written as the product of a leading coefficient, c, and n linear factors. So n linear factors matches the degree, that is n. This theorem implies two important points for polynomials of functions degree greater than or equal to 1. Point 1, every polynomial function can be written as a product of its factors and a leading coefficient. Point 2, every polynomial function has the same number of factors as its degree. The factors may be real or complex and may be repeated. In this lesson, we will consider only polynomial functions where the leading coefficient c is either 1 or -1. In lesson 10, we will consider polynomial functions with leading coefficient other than plus or minus 1. So the graph of p of x equals x cubed minus 2x squared minus 5x plus 6 is shown. The polynomial has integral zeros, so that means each x-intercept is going to be an integer. So use the graph, state the zeros. Well, it looks like we have a scale of 1 on the x-axis, so we can say, sorry, not -4, -2, 1, and 3. The factors that go with each one, well, one factor would be x plus 2, x minus 1, and x minus 3. So writing the polynomial in factored form, since we know we have a positive leading coefficient, we can multiply the three factors together. You could graph this in factored form now, and you'd notice that the two graphs would be identical. Example 2, using graphic calculator to sketch the graph of the polynomial function p of x equals -x cubed plus 4x squared plus 7x minus 10. So when you graph it, it looks something like this. It has x-intercepts -2, 1, and 5. So graphically, those are pretty easy to find on your calculator. So write the polynomial in factored form. Well, now we see that this should have a negative leading coefficient. So we can simply write p of x equals -1 times x plus 2, x minus 1, x minus 5. Of course, you don't actually really need to write that 1. Most of the time, there'll just be a negative sign in front. D, circle the correct alternative. The left arm of the graph, in this case, the left arm is rising. The right arm of the graph is falling. The degree of the polynomial is odd. The leading coefficient of the polynomial is negative. So if you were to step through the assignment, you do the investigation we did in class, which allowed us to summarize a few things. It allowed us to summarize that if we have an odd degree, the two arms are going opposite directions. One is going up and one is going down, like in this example. If we have an even degree, such as a quadratic or a quartic function, both arms go in the same direction. We also discovered that if we have a negative leading coefficient, the right arm is going down always. If we have a positive leading coefficient, the right arm goes up.